The second example in the series includes a different combination of operations. You are in numerical solutions to C problems. Given matrix P of 3 by 3 size, determine the following operations. Interpreting the notation, the innermost is with subscript ij, which requires cofactor. There is also a dagger, which denotes a tranjugate. There are the moduli, which ask for determinant. The order of operations for this example starts with cofactor of matrix P. Then, take the tranjugate of the cofactor of matrix P. And last is the determinant of the tranjugate of the cofactor of matrix P. First is the cofactor. In taking the cofactor, generate the minor matrix first before taking the individual determinants. For element 1, 1, the minors are 1 plus 3i and 5 plus I, with 4 minus 2i and 0. Element 1, 2 has row 1 and column 2 covered, and the minors are 4 minus 3i and 5i, with 4 minus 2i and 0. For element 1, 3, the minors are 4 minus 3i and 5i, with 1 plus 3i and 5 plus I, after covering row 1 and column 3. Moving on to row 2, cover column 1 and have the minors 2 and 5 plus I, with 3 minus I and 0. Right at the middle of the matrix, the minors taken are 3 plus 2y and 5i, with 3 minus I, with 0. And to complete the second row, the minors are 3 plus 2y and 5i, with 2 and 5 plus I. For the third row, we start on the left element's minors as 2 and 1 plus 3i, with 3 minus I and 4 minus 2i. Element 3, 2 has minors of 3 plus 2y and 4 minus 3i, with 3 less I and 4 minus 2i. Then the last element to complete the minors matrix is taken by covering the third row and third column, having 3 plus 2y and 4 minus 3i, with 2 and 1 plus 3i. After completing the minors matrix, take the determinants of each 2 by 2 minors to simplify elements. For element 1, 1, the determinant is computed as 1 plus 3i times 0 minus 5 plus I times 4 minus 2i. This is simplified as negative 22 minus 6i. The determinant of the next element in the first row is taken from 4 minus 3i times 0 less 5i times 4 minus 2i. The first term is zeroed out, and you can use FOIL method or just plug in complex numbers in your calculator to have 10 plus 20i. Complete the third element's determinant of the first row by taking 4 minus 3i times 5 plus I minus the quantity of 5i times 1 plus 3i, the result of which is taken as 38 minus 16i. For the row below, start with the first determinant from 2 times 0 minus the product of the binomials 5 plus I and 3 minus I. This is simplified as 16 minus 2i. The determinant of element 2, 2 is solved from the difference of 3 plus 2i times 0 and 5i times 3 minus i. The result is negative 5 minus 15i. For the last element in row 2, the determinant is taken from 3 plus 2i times 5 plus i minus 5i times 2, which is simplified as negative 13 minus 3i. To finish the determinants, element 3, 1 is simplified as 2 times 4 minus 2i minus 1 plus 3i times 3 minus i. This gives 2 minus 12i. The next element's determinant is computed as 3 plus 2i times 4 minus 2i. Subtract the anti-diagonal elements product from 4 minus 3i and 3 minus i. The outcome is 7 plus 15i. Then lastly, element 3, 3 has a determinant of 3 plus 2i times 1 plus 3i minus 4 minus 3i times 2, giving negative 11 plus 17i. So the simplified cofactor of matrix P is as shown, although still needing the last step to complete the operation, that is, to generate sign reversals from element 1, 1. Multiplying positive 1 to specific elements would not affect the results, although those with negative 1 scalar will definitely flip the signs as shown in the complete cofactor of matrix P. The next operation to consider is the dagger with the cofactor. The dagger means conjugate, and this operation requires two steps. One is to create conjugate, which is basically flipping the signs of the imaginary numbers. The notation of conjugate is bar, and the elements inside are transformed such that A11 becomes negative 22 minus 6i. The element below it is 16 plus 2i, and the one under is 2 plus 12i. From the second column, the element on top is taken as 10 minus 20i. The one below is negative 5 plus 15i. And the last element is negative 7 plus 15i. For the third column, the elements are 38 plus 16i, negative 13 plus 3i, and negative 11 minus 17i. The second step to achieving conjugate is to take the transpose of the conjugate, and by transpose, we only interchange rows and columns. Thus, the conjugate of the cofactor of matrix P is as shown. As the operation is completed, we can take the determinant to have the final answer. With a 3 by 3 size, work on Sarri's rule. Mirror the first two columns and start by multiplying elements in the diagonals and treat them as positives. The first diagonal has elements negative 22 minus 6i, negative 5 plus 15i, and negative 11 minus 17i. They yield negative 7,300 minus 100i. The second diagonal elements are also multiplied. They are 16 plus 2i, negative 7 plus 15i, and 38 plus 16i. And their product is negative 9,012 plus 6,316i. For the third diagonal, the elements involved are 2 plus 12i, 10 minus 20i, and negative 13 plus 3i. Multiply together to have negative 3,620 minus 260i. Add all positives and arrive at negative 19,932 plus 5,956i. solve for the negatives too. The first anti-diagonal has elements 38 plus 16i, negative 5 plus 15i, and 2 plus 12i, which provide a product of negative 6,740 minus 4,180i. The second anti-diagonal has elements negative 13 plus 3i, negative 7 plus 15i, and negative 22 minus 6i, which when multiplied give negative 2,308 plus 4,476i. The last set of elements from the third anti-diagonal has negative 11 minus 17i, 10 minus 20i, and 16 plus 2y, resulting to negative 7,300 minus 100i when multiplied. With all negatives determined, add them to have negative 16,348 plus 196i. Then take positives minus negatives to have negative 3,584 plus 5,760i. This is the final answer.